Ladies and gentlemen, Mr. Brescher here, and today we will all be able to solve one-step equations using inverse operations. We will also look at some real-world problems in which we use inverse operations to solve one-step equations. Specifically today, we're looking at addition equations. All right, first, let's move on. It's also my goal by the end of the class, maybe you'll have a new way of thinking of some of these different equations. Here we have a problem. A hippopotamus can hold its breath for 15 minutes and 25 seconds. 15 minutes and 25 seconds. If the hippo can hold its breath 5 minutes and 10 seconds longer than the sea otter, how long can the sea otter hold its breath? Well, we have to notice that it does say longer than, and I'm just going to give you a different way to think of this problem. If you want, you can try to write an algebraic equation that can be used to solve this. But I want to start thinking of it in a different way. So here we have a model, my little hippo pal, all right? And he can hold his breath for 15 minutes and 25 seconds. And we said that he can hold his breath 5 minutes and 10 seconds longer than the otter, the sea otter. So that means that 5 minutes and 10 seconds plus however long the sea otter holds a breath should be able to equal the amount of time that the hippopotamus has. So notice here that this rectangle the hippopotamus is in is the exact same size as the two combined rectangles down here with this time and the sea otter. We're going to use this kind of model to help us better understand what's taking place when we're solving or writing equations, specifically addition equations. Let's look at some other examples and we'll come back to this problem. All right, first we need to examine some academic vocabulary terms, inverse operations, and the subtraction property of equality. First of all, when we're examining these terms, we want to look over inverse operations is and operations which will undo, okay, or reverse. I'm trying to highlight here. Undo or reverse one another. So how will we undo one term from another or reverse that? Okay. And an example of an inverse operation might be in order to undo or reverse subtraction, we would use addition. Okay. Or in order to undo or reverse this addition part, we would have to use the inverse operation, which is subtraction. Okay. In this example, we have subtraction. Notice it's being subtracted the same amount on both sides of this particular problem. Okay. That is what the subtraction property of equality states, that if the same value is subtracted from both sides of the equation, then the sides will remain equal. So, can you answer this question? What is the inverse operation for subtraction? That's correct, addition. Okay, and what's the way to undo or reverse addition? Correct, subtraction. How would you reverse multiplication? Yes, with division. And you would reverse division with multiplication is correct. Okay, I think we got a good understanding of our vocabulary terms. So let's look at this model. What is actually taking place when we're solving a one-step addition equation? First of all, we can think of one side of the equal sign as the whole, the total value. Okay, and the other side of the equal sign is one part plus another part. Obviously, these parts are different sizes, though. This one is a larger part, and this one's a smaller part. But if we add the parts together, we get the whole. We could also write it this way, in which the whole is equal to one part plus the other part. So that's kind of our basic understanding when we're using this model. Let's use the model to solve a real-world problem here. Okay, here I have my little puppy pal, Spot. And Puppy Pal was a chubby little puppy whenever he was just a puppy, but he grew up. In the last 6 months, he put on some pounds. Now he's a chunky puppy. Okay, so if his total weight now is 46 pounds, and his original weight was 8 pounds, how could we use this to write an equation? Or could you write an equation to represent this? All right. What did you come up with? If we use the complete word form, you might have put 8 pounds plus the weight gained is equal to 46 pounds. Okay? And if we tried to simplify this just a little bit, we would say that 8 plus, I don't know, W for weight is equal to 46. Can you write it another way? That's right. You could also write W plus 8 equals 46. Or you could write 46 equals W plus 8. Does anyone know what property allows us to change the order of this addition problem? 8 plus W becomes W plus 8. That's right. The commutative property of addition allows us to change the order. It says that it will still give us the same value even if we add them in a different order. So you can flop those around. We can also flop the 46 on the other side of the equal sign as long as we're taking the entire value and switching it back to the other side. Okay, let's go ahead and try to solve this problem. If we were to solve it, the first thing that we would do, I have here my little problem, 8 plus W equals 46. And again, we can change the order here and rewrite this as W plus 8 equals 46 because of the commutative property of addition. The next step, we want to undo or reverse the plus 8. We want to get the variable by itself, to isolate the variable. That's our goal. So how will we get rid of adding 8, or what's the opposite of adding 8? That is correct. We would subtract 8, but whatever we do to one side, we must do to the other. What property tells us this? Excellent. The subtraction property of equality. Now we're simply going to simplify. 8 minus 8 is 0, so we have W plus 0, and 46 minus 8 is 38. In our final step, W plus 0 is the same as W. Does anyone know what property tells us this? That is correct, the identity property of addition. All right, we're going to be practicing some of these with some more problems. Let's move on. Here we have another problem. Spot's going to help us out, okay? Roof, roof. The whole is 8 4/10, and the parts are P and 4 7/10. So can you write an equation for this? Okay, let's try to write it. See what you got. P plus 4 7/10 equals 8 4/10. Okay, now we're going to take this problem and use the steps to solve it. You can pause it and then we'll go over it. Okay, we're ready to go over it. First thing we're going to do, we rewrite the problem. The second thing, we want to undo or reverse whatever is happening with the variable. So I want to isolate this variable. I want to get it by itself. I need to reverse this step right here. How do I reverse adding 4 7/10? That is correct. I would subtract 4 7/10. So I'm going to subtract it from both sides because subtraction property of equality tells me whatever I do to one side, I must do to the other in order to keep them equal or equivalent. Next step, I'm going to evaluate. And we get this. P plus 0 equals 3 7/10. Don't forget to line up your decimals when you're subtracting decimals. And the next step, we get this. What property allows us to go from P plus 0 to P? That's right, the identity property of addition. Okay, and you always want to check your solution by plugging in the actual value for P. So we have the quick version of checking our answer right here. Okay, I'm plugging in that value for P and checking to make sure I got the correct answer. And once I know I do, then I can give myself a little smiley face or a check mark or whatever you want to do. Smile because it makes you happy. Moving on. Next one. Here we go again. The top we have 25 now, and the two parts are K and 17 80 hundredths. Can you write an equation? It should look like this. All right, go ahead and try to solve this one on your own. Pause the screen and push play when you're done. We'll go over it. All right, so how did you do? Let's check your work. First step, you should have rewritten the problem, and the second step is focusing on undoing this. How will I get the variable isolated? How do I get the variable by itself? I have to get rid of this. What's the opposite of addition, or the way to undo or reverse it? Subtraction. So here we go. I'm going to subtract 17 80 hundredths from both sides because of the subtraction property of equality. Moving on. Evaluate or simplify. We get this. Final step. This because what tells us that K plus 0 is the same as K? Identity property of addition. Okay, and always, always, always check your answer because we all make mistakes, even teachers do. All right, so we're just going to plug in the value for K, and once again, I'm going to give you the quick and easy version of this right here. Okay, I plug in the value for K, and when I add them together, again, don't forget to line up the decimals when you're adding and subtracting decimals. Okay, and when we line them up and add them together, we come up with 25.00 or 0 hundredths. 25 and 0 hundredths. Is that equal to 25? Well, you bet it is. Give yourself a check mark, smiley face, stars, whatever you want. Okay, congratulations, you got that one correct. Now, let's take a look again at our hippopotamus question. Okay, we already drew the diagram. The hippopotamus holds his breath for 15 minutes and 25 seconds. Now, use what we've learned in our previous few problems to try and solve this problem. I'm going to go over it right now. First off, you should have come up with the fact that we have S plus 5 minutes and 10 seconds, okay? And that is equal to the value of the hippopotamus. I better write seconds here, okay? That's equal to the hippopotamus value, which is 15 minutes and 25 seconds. I'm just going to put M, and I'm going to put 25S for seconds, okay? Don't confuse that for meters. It's minutes. All right, the next thing, what would my next step be? Well, I want to get rid of this. Well, what do I do to get rid of this part? I need to subtract that same amount from both sides. So go ahead and subtract that same amount from both sides. Okay, and once you have that, the next step is going to be to simplify. So I'm going to simplify this. 5 minutes and 10 seconds minus 5 minutes and 10 seconds equals 0. Okay, so I have S plus 0, that's the sea otter, plus 0 time, is equal to 15 minutes and 25 seconds minus 5 minutes and 10 seconds. Again, in this case, I would probably stack these up and down, subtract the seconds, and then also subtract the minutes. It works out pretty nicely, which we have 15 seconds and 10 minutes remaining, but sometimes you may have to actually borrow a minute. And remember, there's only 60 seconds in a minute, not 100. So be careful when borrowing there. But we're left with 10 minutes and 15 seconds for the sea otter. 15 seconds. So how long can the sea otter hold his breath? 10 minutes and 15 seconds based on this equation. Well, I hope this helped you out with solving addition equations. See ya.